subtraction sign is in front of the y squared or the x squared. So not in front of the x or the y term, but in front of one of the squared terms, then you have a hyperbola. Okay? All right. We're going to figure out how it opens. So if you look at that sheet that I gave you, hyperbolas don't open towards each other. They open outwards. And how it opens is determined by which one is positive. So, where's the negative sign? If the negative sign is in front of your y, then the x is positive and your hyperbola opens along the x-axis, or left and right. Okay, in this case, my negative sign is in front of my y terms, right? That means this is my positive term, correct? That means it's going to open left to right. If the y minus k quantity squared is first, which means it's followed by the minus the x, then it's going to open up, down. Okay? So you're going to want to figure out the orientation. This has nothing to do with the denominators. How it opens has nothing to do with the denominators the way it is determined in the ellipse. It's the sign that determines how it opens. Do you understand the difference? The sign. The sign being positive, which one is the positive term and which one is the negative term. Okay. I have a minus sign here. This is the first time I've ever seen a minus sign between my x and my y. Oh, so you could have a plus there, but a minus in front of there. This one, then whatever is positive is the direction that it opens. Okay. Okay? Has nothing to do with my denominators. Okay, go? All right. You have asymptotes, because if you look on your little sheet, your asymptotes are those diagonal lines. They're an equation of a line, and they will determine how wide or how narrow your hyperbola is going to open. Okay? Okay. And it's determined by plus or minus m, x minus h. All right, so this is y minus y1 equals the slope times x minus x1. It's in that format of the equation, right? So you can think of y minus y sub 1, right? Y minus k is our center of our y, right? And then plus and minus. We're doing plus and minus because we're doing a positive slope and a negative slope. And then it's x minus x sub 1. So we need to know what our slope is. And how do we determine the slope? Slope is determined by what? Change of y over change of x. I'll show you all this as we progress, okay? Okay. Change of y, change of, there's always two equations. Your center is hk. Just like it, we'll get to it. Let me just go through an example and you'll see what I'm talking about. Okay. All right, center is hk like it has been for a circle and it has been for a ellipse. So the center hasn't changed in how we determine what it is. Today, your center is going to be at 0, 0. Okay, so we'll start out with the vertices. They lie on the axis that the hyperbola opens. Okay.
That'd be the F points.
Huh?
Like in the picture, are those the F points?
No, F stands for focus.
Oh.
V, you got V. See the V? There's a V.
Oh.
Those are your vertices. Okay?
So hyperbolas are always gonna be opposite from each other?
Yes. They open away from each other. Okay. All right. Focal points will always lie on the axis that the hyperbola opens out. When you look at this, hyperbolas are opening around your focal points. Right? So they're not in between the vertices now, they're on the outsides of the vertices. So their values at C will be bigger than any of the A's or the B's. Does that make sense? All right, your focal points always lie on the axis that hyperbola opens around. And here is your equation. Why is this one different from your other one? What makes this one different? I'm adding. Okay, so here's how I remember. If I'm dealing with an ellipse, my general equation is a plus, right? X squared plus y squared is equal to 1. But our focal point formula, what do we do with those A's and the B's? We subtract. So they have opposite signs. You're never going to be doing the same thing. In this case, the general equation has a minus sign in it, so what am I going to do with my a squared and b squared? Add it. That's how I remember. That's my little device to remember when do I add and when do I subtract. Does that make sense? Y'all, are you following my thought process here? Okay. So, C is the distance from the center of the hyperbola to the focal point, and A is the distance from the center to the vertex. A and B are not going to float. What floats is the direction, so your x and your y will float. Sometimes your x will be first, sometimes your y will be first. Are you following that? So, this opens which way?
Up and down.
Up and down. Why is it up and down?
Because
The y squared is positive, so this opens up and down. And
you have sound, you know.
I tried to run my sound, but obviously I couldn't.
Yeah,
Try something else.
Okay, what was wrong?
That is to be technical.
What is my center? 0, 0, right? Because my h and my k are 0, 0. Now, be really, really careful with this, guys. My y value and my x value will move.
oh, so like, it's like the A and the B thing, where the A will be the bigger one?
But that's not the case with hyperbolas. Okay, that's where my ellipses are, but the a and the b don't float, the x and the y float. Okay, all right. What is your A?
3. 6.
A is 6.
Well, that's what I was asking, I guess I just phrased it wrong.
Okay, what is my B?
Wait, how do you know it's 6?
A, in this case, A is always under the x and B is always under the y. That's what I'm saying. The A and the B don't float. The x and the y float.
So every time the A is going to be from the X.
Yes,
I mean, so it's always?
always for hyperbola. Okay. All right, what is my B? What is my B?
3
3, right? It's a square root of 9. Yes? You with me? And my C. What's my formula to figure out my C?
36 plus 9.
Equals C squared, so that's the square root of 45, which is 3 root 5. And for plotting purposes, what is 3 root 5 as a decimal? Okay, I want to make sure. Hold on a second. Let me look at something for a second. Make sure I'm saying something right.
People that don't have a class anymore, like the sophomores that are taking higher classes,
Uh-huh.
are you done with your class completely?
Uh-huh.
Like
Well,
grade 3
tomorrow.
period?
Well, I have juniors and juniors, and they're taking their exam, and then they're
Are there
going.
any sophomores?
There's one sophomore, she's not done.
So she's just gonna have one of them?
Yeah, there's a one sophomore.
Merritt Nowak. Huh?
She's really interested.
Yeah, is she, yeah, what's she doing?
She has to learn the geometry stuff.
By herself?
No, why would I have her do it by herself? Does that even make sense? I would have her I'm gonna have her come meet with me. Okay, I did this wrong. I said something wrong. I said something wrong. I had to check. Sorry. Let's look at this. My A, sorry. My A is 3, and my B is 6. Yeah, sorry.
So they're always be the first one that's on.
Sorry.
Wait, that makes no sense. So A is always.
A is first, yeah.
Wait, A is always the first one, and B is always like no matter whether it's X or Y first.
Yeah, let me look again, make sure, because I don't want to confuse you again. I'm just looking at something that I did. This is, A is 5 and B is 6. Yep. See, on another example, A was, yeah. I just want to make sure I was doing it right. Okay, so A is my first one and B is my second. Okay? Sorry. Any confusion. All right, so let's graph it. Yeah. All right, so where's my center? And how does this open?
Up and down.
Up and down. Okay. And so how many units do I go up to get to my 1, 2, 3? That is a vertex. 1, 2, 3. That is a vertex. So the coordinates of the vertex then are 0, 3, and 0. Correct. Okay. And for argument's sake, we want to know what we're going left and right. We're going to go left and right how many units from the center? 1, 2, 3, 4, 5, 6. I want you to put a point here, but not really use it. What we're going to do is we're creating a rectangle with this. We're going to drop this up to the vertex, over, down. We're just creating a box. Okay? So we went up and down 3 for our vertices, yes? Because we knew it opened up and down. And then we're going to go left and right that B value, which is 6, so that we can create a little rectangle. You with me? Okay. This little rectangle is what allows us to draw the asymptotes. The asymptotes are going to go through the corners and the center.
You want us to do this on like our homework?
Yes, everything that I'm doing, you're going to want to do, so that you get the shape right.
So do the dot lines and everything?
Yes.
Is that okay if they're not different colors?
Perfect, yeah.
Does it have to be dotted or things as well?
It has to be dotted because it's an asymptote. It's not an existing line. It's an imaginary line that exists in the picture. So again, how does this open?
Up and down.
Okay, we have now provided guidelines with which to create our hyperbola. This is a vertex. It hits this value. It opens to this vertex and to this vertex, or I mean to that asymptote. And then down here, it opens here and here. So the reason we have that second value is to create our little rectangle. Does that make sense? So that we can draw our asymptotes in through the corners and then give us the shape of the hyperbola.
Oh. So you can't just like wing the hyperbola and make
You
it.
cannot just wing it, no. All right, now the only thing that I'm missing 2 things. I'm missing my focal points. Now my focal points, are they going to be left, right, or up, down?
Up, down.
Up, down. And they're going to be in between these vertices or outside.
Outside.
Okay, how many units am I going to go up and down? So 3 root 5. So it's going to be 0, 3 root 5, and 0, negative 3 root 5. And so we're at about 6.7, right? 1, 2, 3, 4, 5, 6, 7. So here is that focal point. And here is the other one.
Oh, so we have to go up.
From the center, how many units do I go? Up 6 and down 6. And a half.
What's the purpose of the focal points?
The focal points are, from this point, we will get the same distance on either side.
And you go from the center, not from the
Always, every movement is always from the center, just like in the ellipse when we were doing our focal points, right? Okay, so now we need to do our asymptote equation.
We already have an asymptote. Why
We have them drawn, but I want to know what the equation is for them. Okay? Uh-huh.
Do you want us to draw the little like box thing?
I do, and dotted. I want
I
it
mean
dotted.
the for the focal points, like connecting them. Like the half box from one dot and then like the line and then
No,
like that.
I don't need any distances.
Okay.
All right, equation. I said it was y minus, what is that, k? Equals plus and minus m over x minus h. Is that right? And k and h are our center, right? So what we really have so far is y minus 0 equals plus and minus x minus 0. Because we're at the center. Would you agree? We're at the origin, right? Okay, now we need to figure out our slope. Slope,
Wait, where did you, or I just dropped out in a second.
I haven't done it yet. I forgot it. I'm going to figure that out. So what we need to do is figure out our m.
Would you put in 3 for y, or 3 for y, and 6 for x?
3 for y and 6 for x. Absolutely.
And you have to leave this.
And so what is that in reduced form? So now we have y, we don't need that minus 0, do we? Equals plus and minus 1/2 times x, right? So that means y equals 1/2 x and y equals negative 1/2 x. And these are my two equations for the dotted line. So I did go up 3 and over 6, didn't I? Isn't that how I got to that corner? I can go up 1 and over 2, up 1 over 2, up 1 over 2. I'm going to get to that same corner eventually. Yes?
And we have to write it out as this, or we can just do y equals plus or minus.
Well, what's going to happen is our center is not going to be at the origin anymore. So you want to get into the habit of writing as two separate equations. Does that make sense? Okay. All right, so this is what I gave you. So we have a center. We have focal points that fall outside. Vertices that we connect our hyperbola to. Asymptotes that determine how wide our hyperbola is going to be. Make sense? All right, look at the next one. How does this open?
Side to side.
What's my center?
0, 0.
Today it's pretty. It says 0, 0. Huh? Which one's positive? Which term is positive? Better? Okay, what's my A?
3, 3.
We get it right this time. What's my B?
4.
And so C, that's going to be, C squared is going to equal 16 plus 9, which is?
Oh, it's plus.
Right? Yeah? And so C is? 5. Is that what we did on the other one? Did we do plus? Yeah. Okay. So, once we get some of this basic information, the really graphic is going to help you figure out the rest. All right, so we're going to start by plotting our center at the origin. Again, how does this open? So when we get to my vertices, I go left and right how many units? Yes, are we good? Which gives me our vertices at 3, 0, and negative 3, 0. Well, we're going to go up and down certain units to draw a rectangle, but there's no co-vertices right. Okay? So I'm going to go up and down how many units? 4. 1, 2, 3, 4. 1, 2, 3, 4. And dot in your rectangle. And then draw in your asymptotes. Right up in the middle and the corners. How does this open?
Side to side.
So that means when we draw this, hitting our vertice, we're going to open it up, down, here, up, up. So you've got to remember how it opens. We said it opened left to right, so you got to be using the right corner or point. Okay, focal points fall at what coordinate?
5, 0, 5, or 5, 0, and that's
Right. 5, 0, and negative 5, 0. Your asymptote, no. Your focal point is your C. C was 5 units left and right. Right? C always represents, in any of these last two lessons, C always represents the foci. Okay. So now we need to do the asymptotes, don't we? We have to come up with those. Oh, I see why you're confused. I put this in the wrong spot, didn't I? Sorry. So this is 5, 0, and negative 5. Sorry. And so we do our asymptote equations. We're going to say y minus 0 equals plus and minus m times x minus 0. Because we're at the origin. What is my M?
4/3.
It is, what is our Y value? 4. And our X value is 3. So Y equals plus and minus 4/3 X. So Y equals 4/3 X. Y equals negative 4/3 X. Make sense? Yeah. Okay. Why do I know that this is a hyperbola, Abby? You with me? And not an ellipse. What in this problem? Because it could very well have been an ellipse. But why isn't this an ellipse? Okay.
There's a subtraction sign or negative sign before it equals the y squared.
The squares, right. Okay. If this had been a plus sign, it would have been an ellipse, and we would have found all the information for the ellipse. Okay. So a hyperbola has to be set equal to what? 1. So we're going to treat it like we've done it in the past. Set it equal to 100, but if it has to be set equal to 1, that means every term is then divided by 100. Which then leaves me with x squared over 25 minus y squared over equals 1. We've got it in standard form. The center is located at, and we know in this case, which way does it open? Which means my A is, and my B is. Okay, and my C squared is 25 plus 4, so we know that C is the square root of 29. See how that's all kind of falls into place? So we're going to start graphing. We're going to do 0, 0. We're going to go left and right, what? Put our little dots there. And then for our box purposes, we're going to go up and down how many units? And then we're going to dot it all in. So this is really going to be kind of a narrow looking hyperbola, isn't it? Would you agree?
Yeah.
Then we're going to put our dotted lines in through the center and the corners to get our shape. Again, how does this open? So when we draw our hyperbolas, we're going to go, make sure, I'm going to be picky. You got to hit the vertex. You got to come from the vertex. So don't just kind of slap it in. I want to show me that it's coming through to the vertex, touching that point. Nope, you're going to the center. Don't go to the center. Don't, see, there's my center.
Oh, okay.
Go to my vertex. Check your other ones, make sure you get those. Okay, so my vertices are at 5, 0, and good. My focal points then are going to be at and negative root 29, 0. And then we need to do our, what is square root of 29 as a decimal?
5.38.
So we're going to go 1, 2, 3, 4, 5. We're just really close, aren't we? Sometimes we're very close to the vertex. So we know that we have y minus 0 equals plus and minus m x minus 0. What is my slope? 2 over 5. It's the y value. Where's your y? What's under the y? Where's your x? What's under the x? Okay, the square root of those values. So 5/2. So y is equal to plus and minus 2/5 x, which means y equals positive 2/5 x, y equals negative 2/5 x. Those are my equations.
It's 2, okay, because you just said it was 5/2, it's 2/5, right?
What did I say?
Oh,
I'm sorry, yes.
Yeah,
That's my bad. Sorry. Sorry. Who's that?
Oh,
She went to your lessons.
Oh, yeah.
Oh, this is math.
I would
Just
have,
miss chemistry and
I like actually only went on a B day because we dropped math. I'm dead serious, like I'm not scared of missing it.
Yeah, I go on to be there.
All right, can we get this? Is this making sense? Follow those steps, okay?
maybe the rest of it.
Yeah. All right, get that homework out.